So welcome back to the channel guys. Hope you are doing extremely well and this is your very own mass coder this side. So welcome to yet another lecture of binary tree. It is lecture number 15 I guess, and the problem of the day is construct binary tree from post order and in order. The problem is an exemplary problem and it is very good to solve to clear up the concepts, right? Before it we just made a binary tree from pre-order and in order. Pre-order and in order, the concepts are gonna be exactly same, just the order will change, right? Okay, so if you have not watched this, please watch it down, and the description provides the link of this particular video, and I hope you are following the binary tree full series to master it, right? Okay, the problem is simple. Up till now, we from the binary tree we were actually getting the traversal. Like this binary tree was giving me the post order as this one and the in order as this one, but now the process is reversed. The process says merge these two traversals and give me this binary tree and give me this binary tree. The post order is given to me as 9, 15, 7, 23, and the in order is given to me as 9, 3, 15, 27. You can check that the binary tree post order will be exactly same and in order will be exactly same. But how to proceed? How to proceed? So the answer to every problem lies in the question and the definitions and the definitions and the definitions. So if I say what is the definition of post-order traversal, if I say what is the definition of post-order traversal, so you will say the post-order traversal says explore the left subtree first, then the right subtree, and then the root, and then the root. And similarly, in order says explore the left subtree, then come to the root, and then explore the right subtree. Right? This is what the post-order in order say. Right? So if I try to stress upon this post-order traversal, I am able to see that root is coming at the last. Root is coming at the last. That is, this value, this particular value is gonna be the root of the tree always. The last value of the root of this traversal is gonna be my root. So I can surely say that 3 is gonna be my root of the main tree. Right? Now I want to get the left part and the right part. The left part and the right part. Okay, so how can I get it? Like I want to find the distinction, right? It can be that left part is up till here and right part is only this, or it can be left part is up till here and right part is this, or it can be left part is there and right part is this. Are you able to understand? They can be anywhere, right? They can be a distinction anywhere. The distinction can be here, can be here, can be here, can be here, can be here. Anything can happen. So how can I decide whether it is correct? Like where should I find the distinction, right? If I'm able to see that this is my root, that means this is my root. If this is 3 and this is 3, then both of them are root. And in order says that on the left side of the root lies my left subtree, and on the right side of the root lies my right subtree. On the left side of the root lies my left subtree, and on the right side of my root lies the right subtree. That is, 3's left gonna contain only 9, and 3's right gonna contain 15, 27. 15, 27. Okay, so this is only one node, that means I can say that it is 9. But what about 1527? What will be the root here? Again come to the post order traversal. Now 1527 is also a subtree, so it will also follow the properties of the post order. Among the 1527, 20 is the last node in the post order traversal. That means 20 is gonna come here. 20 is gonna come here. Now again, 20 is gonna come here, but what about 15 and 7? Where the 15 is at left or 15 is also at the right, right? So what will I do? I will find 20 here. 20 I found here. I can see 15 is on the left. That means the left part will contain 15 and 7 is on the right. That means 7 is going to contain, right part is going to contain 7. Only one nodes here, so 15, 7. And you can see these are the exactly two trees which are matching, and this is the only unique tree which can be generated with the post order and in order. Now when I say unique tree, why do I stress upon unique tree? Whenever you are given a post order and in order, and it has been given that this post order and this in order can generate a tree, the tree is always unique. Why? Because of the distinction, because of the distinction of the left part and the right part, left part and the right part. If the question only gives you the post order and say that make a tree out of it, you can say that I will choose whatever distinction I want. I will say that all of these are in the left subtree, and 3, all of the elements are in the left subtree, then 20, then 7, then 15, then 9, etc. Like something like this, right? This post order is also gonna give you a binary tree which is following this post order, right? But when you add an in order, then the tree becomes unique. Then the tree becomes unique. Okay. So I hope I'm clear with you. Now, how to write the code? The main part is how to write the code. How to write the code. So one thing we are able to judge is that what we did for 3, like distinctly getting the left part and the right part, is exactly the same what we did for 20. The process for 3, what I'm saying is the process for 3 is equals to the process for 20, right? Process for 3 is equals to process for 20, but 3 had all the array. 3 had all the array to select from, but 20 had only these 3 elements, right? So something like recursion is happening. Recursion is happening. Like I'm repeating the process for elements. I'm repeating the process for elements, right? So my post order is given to me as, what is my post order? My post order is 9, 15, 7, 23. So 9, 15, 7, 23, and my in, this is my post order, and my in order is given to me as 9, 3, 15, 27. 9, 3, 15, 27. I have these in my hand. Now what will I do? In the first, when I will be calling the recursion function, let us say my recursion function is f, right? It will have some parameters, and my main function, my driver function, let us say driver function is here, right? Suppose the size is given to me as n, and n is the size of the element, that is 1, 2, 3, 4, 5. So n is 5 in this particular case. What will driver call? What will driver call? Suppose driver will call the f function, right? F function, it will send the post order, it will send the in order. Now in the first iteration, like when I'm calling the function, I will be sending all the values from 0 up till n minus 1. So I will say my post order is starting from 0 up till n minus 1, and similarly my in order is starting from 0 up till n minus 1. So f will get parameters, the post order traversal, the in order traversal. Along with that, it will get post, start, post, end, in, start, in, end. What do I mean by that? For example, when we were judging about 1527, you can see that in start and in end were like this, and post start and post end were like this. They are both different. You can see 15720 have different indexes than 1527 in the in order, right? So I will have to get 4 parameters for post start, where the traversal is starting from the post order till post end, and similarly in start and in end. Now when will I stop my, what is like recursion always has a base case. What is the base case for this problem? What is the base case for this problem? The base case for this problem is if post start actually exceeds the post end, which is not possible, right? Which is not possible. That is, I'm saying the left pointer comes in ahead of the right pointer, comes at right of the right pointer. That is not possible, right? In that case, return null. That is, you cannot make a tree out of this condition, right? If post start is greater than post end, return null. Otherwise, if post start equals to post end, the condition which occurred in the case of 9 and 7 and 15, you can see only one element which is equals to one index, that in post start and post end are equal. So you will say just return a new node with that value, return new tree node with that value. What is the value? Post order traversal of post start, or you can post end also, or you can use in order also, because the value is gonna be same at last. Okay, now the main case arises of the recurrence. Main case arises of the recurrence. So what are the steps we did? In the given array, we just found 3 first. We found 3 first in the last of the post star. Then we found the index of 3 in the in order. So do that. So my value is equals to int value is equals to post of post end. Remember post end. I'm getting the root element from the end part. Okay. Now index equals to -1 for I going from in start up till and inclusive of in end. What will you do? You will say if in order of I equals to that value which we want to find. What we will do? We will say our index is equals to that I, and we can simply break. Now if I try to see the example we were using, we found this 3. Now what are the number of elements on the right? So if this is my int start, let me show it here, right? We found 3 here. This is the index. This is 0, 1, 2, 3, 4. In the first iteration, this is my in end, this is my in end, this is my in start, right? What are the elements on the left subtree? So it is one element, that is, if this is my index, and number of elements on the left is index minus in start, and similarly number of elements on the right is 1, 2, 3, that is 4 minus 1, that is in end minus index. I will say the same thing. So left is equals to index minus in start, and right equals to in end minus index, right? I got the number of left elements, I got the number of right elements. Why did I choose this? Because I wanted to find the distinction. Because I have the root. If I have the root, I know that three elements on the right subtree, these three elements on the right subtree, and this one element is on the left subtree. So what will I do? I will just send in the recurrence relation, I will just send this as my post end and this as my post start for the right subtree, and this as my post start and this as my post end in the left subtree, right? So what will I say? If I am standing here, this is my post end right now, and this is my post start. For the right subtree, I want to go from, if you see post and minus 1, this is my limit, post and minus 1, and it is going up till, so I have three elements here. So post and minus 1, post and minus 2, post and minus 3, that is post and minus the number of right elements, that is right, right? This is a for the right subtree. So what I will say root right. Root, right? What is the root here? Have I discovered the root? No, I have not discovered the root. Sorry for that. Root is gonna be this value, right? This root is gonna be the node with this value. So we will just make root equals to new tree node with the value, right? Now root right is gonna be the same function f. You will send both the arrays. Now post order, like post start and post end, is gonna be post start is gonna be post minus right, post start minus right, and post end is going to be post end minus 1. And similarly, what about in order, in start and in end? So you can see, if you find the index here, the right subtree is going to go from index plus 1 up till in end. So write it down. So index plus 1 up till in end, right? This will give you the right subtree of the root. Now what about the left subtree? You also want the right subtree of the root, right? You will call the function, but what about the value? So let us discuss that. For the left subtree, in start is gonna be in start and in end is gonna be in end minus 1. So I've got two values, these last two values. In start is gonna be in start and in end is gonna be index minus 1. But what about the post order, like post start and post end? Okay. So post start was here, which will remain the same, Post start is gonna remain here only, and post end for this one is gonna be, like, I want one element, right? I want one element. So you can see it will be post start plus left elements, that is one element, minus 1, because 0 plus 1 minus 1 will again give me 0. I want to remain here only. This is just an observation, not any, like, not any algorithm or intuition. It is just an observation. So I will say post start is going to be same, and post end is going to be post start plus left minus 1. As simple as that. At last, when both the recursion call finishes, return the root, and you will have your answer in your hand. If you want to know the dry run of it, the dry run is exactly same as I discussed about this dry run. Nothing changes. This dry run is exactly same as that dry run. Okay. So now let us see the code. Hope you are excited to see that code. Here is the coding section, but before starting with the code, I would like to request you to please subscribe to the channel, because it really motivates me, and I will again bring the most amazing content I can bring out to you, right? So let us start. First of all, get the size of the arrays. So in order dot size, right? Now what will I do? I will say return f. What is f? The helper function we will be making. Send the in order there, send the post order there, okay, and now send the in order post start is 0 comma minus 1. This is my post end. Now in start is 0 and post in end is n minus 1, right? Let us define the f. So tree node star, because it is returning tree node star f is taking two arrays, so vector of int in order and similarly vector of int and post order, right? Now I'm taking my post start and my post end. Similarly, I am taking my in start, so int in start and int in end. Now what will you do? You will just set the base condition that if my post start at some point become my greater than my post end, I will simply return null, because there is not a node that is possible to make, right? Otherwise, if my post start equals to my post end, you will just return a new tree node with the value of the last element, that is post order of post end, right? If that is also not the case, then you will have to do the recursion. So make a tree node star root equals to new tree node with the value of post order post end, right? And this is also my value, so I will just say for the simplicity is equals to this value, control X and control V, and similarly I will write value here. Now I will say int index is equals to -1. Now for int I going from post start, sorry in start, sorry, I have to find the value in index. So int in start I less than equals to in end I plus plus. What will I say? I will say if in order of that I equals to the value we are looking for, assign that value and break, right? I needed as value, I got it. Now number of children in left subtree are gonna be, we discussed it, right, are gonna be index minus in start, and similarly number of children on right are gonna be in end minus index, right? Now just the calls, if you remember, you can see in the side also the photo is saying the screenshot just clicked out of the notes we just made. So sorry, root right is gonna be f of, I will send the in order again, I will set the post order again. Now my post start is gonna be okay, post end minus right, right, the number of elements on the right side, and post end is gonna be post end minus 1. Similarly in start is gonna be index plus 1 up till in end, right? And my root left, the left subtree is gonna be f of in order with post order, and the number of like post start is gonna be, now it is equal to post start only, and post end is gonna be post start plus left, the number of elements on the left subtree, and minus 1. And similarly the in start is gonna be in start, and the number of like in end is gonna be index minus 1, right? And at last return the root. As simple as that. Let us try to compile and run it. Hope it will run fine and should not give any error. Oh, there has been some error. Okay, I'm missing a semicolon. Let us try it now. Okay, it is running for the sample test cases. Let us try it for the hidden test cases as well. Hope it will run. And it is getting accepted. So thank you for watching. Hope you liked the video, and if you are able to understand the question, please do not forget to like and subscribe the channel because it really motivates me. I will bring out more content to you, so stay tuned. Thank you. Have a nice day.